Hello and welcome to our IGCSE chemistry class. This is Mr. Dolph and today we're going to learn about states and properties of matter. Oxygen is one of those 118 elements found in the periodic table. Every day we breathe in oxygen because our body requires it in order for cellular respiration to happen. Cellular respiration produces the energy that we need in order to sustain our daily physical activity. Without oxygen, we won't be able to do the daily things that we are doing. Oxygen is also the reason why fire is being supported. Without oxygen, fire won't happen. Fire is the same reason why 78, if not 80%, of the forests are now burning in Australia. Oxygen is also the reason why our body is able to produce carbohydrates, proteins, and fats. And therefore, we can say that without oxygen, life won't be able to happen. However, oxygen behaves in different situations and circumstances. For example, oxygen is a gas at 0 degrees Celsius, liquid at negative 180 degrees Celsius, and solid at negative 218 degrees Celsius. In other words, oxygen can be in the form of gas, liquid, and solid at different temperature. When a substance turns to gas, from gas to liquid, we call that phase change. But the process involved when gas turns to liquid is what we call condensation. From liquid to solid, the process involved here is what we call freezing. For solid to liquid, this process is what we call melting. And from liquid to gas, this process is what we call vaporization. What about from gas to solid? This is what we call deposition. And from solid to gas, this is what we call sublimation. Let's repeat. These are the processes involved in phase change: gas to liquid condensation, liquid to solid freezing, solid to liquid melting, liquid to gas vaporization, gas to solid deposition, and solid to gas sublimation. If we take a closer look, we can see a growing trend in temperature or a decreasing trend in temperature. Let us start with the trend from gas, liquid, and solid. How will you describe the temperature from gas as gas turns to liquid and liquid turns to solid? Does the temperature drops or does the temperature increase? Based on the given data, the temperature drops. How about from solid to gas? The temperature increase. So we can say that when gas turns to liquid and liquid turns to solid, the temperature drops as a result of energy being released. When we release the energy, the temperature drops, since temperature is a measurement of the average kinetic energy present in the particle. When the temperature increases, in this particular case where solid turns to liquid and liquid turns to gas, or solid turns to gas, this is where energy is absorbed. To get us a better understanding, let us take a closer look of our example. So solid, liquid, and gas, as we can see here in our illustration, are moving in random motion, which means that the particles are moving in any directions. Gas moves faster than liquid, while liquid moves faster than solid. Solid is vibrating back and forth or up and down in any direction. In other words, it's moving in random motion. The factor that affects the rate of the movement of the particles between gas, liquid, and solid are the spaces found in between these particles. As we can see that the gas particles, they are more far apart from each other, and the distances are far apart, allowing the particles to move faster as compared to liquid and as compared to solid. Let us take a closer look using a simulation. In this simulation, we'll be able to recognize that there is indeed a difference between the movement of particles, heavy particles, and lighter particles. In this case, let us try to use neon as an example. Neon is a monatomic particle, which means it exists as a single atom, it's a single particle. This is neon in solid form, liquid form, and in gaseous form. Oxygen, on the other hand, is diatomic, which means that it cannot exist without combining with other oxygen atom. This is oxygen in solid form, oxygen in liquid form, and oxygen in gaseous form. However, if you're going to compare the gaseous form of oxygen and the gaseous form of neon, we'll be able to recognize that neon particles moves faster than the oxygen particles. This is partly because the oxygen is diatomic molecule, thereby contributing to greater mass. The greater the mass, the slower the rate of diffusion. The lighter the mass of the particle, the faster is the rate of diffusion. However, in both cases, for neon and oxygen, both behaves on the same aspects, whereby when we increase the temperature, what happens is that the forces of attraction that exist between these particles are being broken down, allowing them to move farther apart from each other. And remember, the moment they break these attractive forces and they move far apart from each other, they become liquid, or they could also become gas. However, when we release the energy found between them, or found between these gas particles, eventually these gas particles forces of attraction becomes very relevant, and in the long run these gas particles condenses and eventually turns to liquid. And when the liquid particles establishes more of its forces of attraction, it becomes solid. The same applies with the neon. Now let's go back to our presentation. Let us try to answer these following questions. I'd like you to pause the video as necessary. Let's answer first for solid. Does it flow easily? No. Liquid? Yes. Gas? Yes. Can it change shape to fill its container? Solid? No. Liquid? Yes. Gas? Yes. Does it stay put and left in one place? Solid? Yes. Liquid? Could be yes or no. Gas? No. Does it always take up the same volume of space? Solid? Yes. Liquid? Yes. Gas? No. Can it be compressed to fit into a smaller space? Solid? No. Liquid? No. Gas? No. You might be asking, how is it possible for solid not to be compressed and the liquid not to be compressed? Well, in reality, they could be compressed, but it takes a lot of effort, a lot of pressure for this solid and liquid to be compressed, and therefore they cannot be compressed in normal circumstances, and thus it's safe to say that they are incompressible. Oxygen, again, is very important for cellular respiration to take place. Oxygen is one of the examples of gas. Gas and liquid flow. But how is it possible that liquid and gas flow? If we spray a perfume in one corner of the room, eventually, after some quite of time, everybody smells the perfume. or when one drops an ink into a clear water, eventually this ink spreads out until all areas of the container has the ink. On the other hand, which happens very slowly, is that when you drop an ink into a gelatin, which is quite a hybrid form, it's a cross-link between liquid and solid, it spreads out. And therefore, gas and liquid are considered as fluids because under normal circumstances, they flow. Solid, on the other hand, does not flow, or it's safe to say that they flow very, very slow. Normally, when one particle is concentrated in one region, they move out or they spread out in all directions until such time that the particles are evenly spread. Because of these characteristics of particles, when we're going to combine two different types of particles of different concentrations, they will eventually spread out naturally across the container until such time that, in this case, the red and the gray particles are evenly spread. This process is what we call diffusion. It is the random movement and mixing of particles. It happens during the time of Robert Brown. Before Robert Brown's time, early people thought that solid objects, the atoms of the solid objects, does not vibrate at all, and liquid that is still does not vibrate at all. However, during the time of Robert Brown, which is a Scottish botanist, he made his assumption that indeed the pollen grains are living organisms. So he made some simple experiment. He gets some sample of pollen grains and drop it on top of the still water. He observed it under the microscope, and surprisingly, he found this. The particles are moving in random motion. So he concluded that the pollen grains are actually moving, when in fact it's not the pollen grains that is moving, but because of the water particles that are moving in random motion, and the moment it collides with the particles of the pollen grains, it eventually moves. Now, what are the factors affecting the rate of diffusion? First is temperature. The higher the temperature, the faster is the rate of the diffusion, because particles tend to obtain the kinetic energy that they need in order to sustain their motion. The size and the mass of the particles, as we can see in the previous examples, using argon, a monoatomic particle, and oxygen, a diatomic particle. Oxygen in gaseous form moves slower compared to argon in gaseous form. The state of the substances that are diffusing: a solid diffuse slower compared to liquid, but liquid diffuse slower than gas. So it depends upon the states of the substances that are diffusing. In your previous projects, you have witnessed how to make a density tower, and in fact, the density is the reason why egg sinks in fresh water and egg floats in salt water. An egg suspends in a mixture of fresh and salt water. This suggests that the egg, in this first picture here, this suggests that the egg is denser than the water, thereby sinking at the bottom part. In this case, the salt water is denser than the egg, thereby floating on the top of the salt water. However, when the density of the egg and the water are the same, they suspend. So density is how heavy something is for its size. For example, a steel, an aluminum, water, and air of the same volume may have different amount of masses. Therefore, they have different amount of density. Let us try to solve this problem. If I fill a cup with 250 ml of gasoline and the mass is 200 grams, what is its density? Using this pyramid technique, we know that density is mass over volume. We simply cover the D and we can find that mass is divided by volume. If you're looking for M, density times volume. If we're looking for volume, mass divided by density. In this case, we're looking for density, and therefore, using this formula, we'll be able to get the answer 0.8 gram per ml. Next problem, I'd like you to post this video and try to answer on your own. The correct answer is 7.57 gram per cubic centimeter. In our previous example, we used the unit milliliter. In our second example, we used the unit cubic centimeter. Both units measures or describes the quantity of volume. The difference is cubic centimeter is the unit being used to describe the volume of solids, while liter or milliliter is the unit being used to describe the volume of liquids. Pause the video and answer. The correct answer is 12 grams syrup. Now this is your assignment. I'd like you to answer these questions and we will share our answers in our next meeting. Density has a very rich history. During the time of King Hiron of Syracuse, the king ordered a golden crown to smith, but he is quite suspicious whether the crown is a pure gold, and therefore he called Archimedes, who is known at the time. So we know that different substances has different density. Gold, if you're going to reduce its mass, it will always have the same density. So the problem of Archimedes is not measuring the mass, because it's easy to measure the mass, they have the weighing scale. But how is he going to measure the volume of an irregular crown? During the time he's taking a bath and he saw water being displaced from the bathtub. So he has this idea that the amount of water being displaced is the same volume that his body is using or occupying in the tub. And this method is what they call the water displacement method. Because of this, he was able to find the volume of the crown. And by measuring the mass, he was able to find the density of the crown, which happens to be the same density of a pure gold. And therefore, he returned to the king, running, naked, shouting the word Eureka, which means I found it. And indeed, he was rewarded. If we are going to blow the balloon eventually expands. It expands because of the air particles found inside. What it does is that the air particles collides with the surface of the balloon, and when it collides, it creates a pushing effect, and this is what we call the force. When force is applied per unit area, that is what we call pressure. The more the collision, the more the force, the more the pressure. However, if you're going to place the balloon in the fridge and the other one in room temperature, eventually we'll see that the one in the fridge eventually shrinks, and that is because the energy is being released, thereby slowing down the particles of the gas. At sea level, there are more air particles because of the effect of gravity. On higher altitude, there is less air particles. Now, it implies if you're going to release the balloon from sea level, the moment it reaches on top, the air pressure outside is less than the air pressure inside, because The lesser the air particles, the lesser is the air pressure. So what happens is that the balloon explodes. In conclusion, the three states of matter are solid, liquid, and gas. The physical properties of matter are volume, compressibility, fluidity, diffusion, density, and pressure. These properties are affected by temperature, state, and mass of the particles. Thank you for listening.